Hello everyone, I'm Ausyellow, and it has been a while. That's because I had a little holiday on the weekend and got sick. Well, I say sick. It's just a sore throat and a stupid nose. I'm going to start a new series on the YouTube channel. Not going to be the most popular series, to be honest. I don't actually need to see this. It's not going to be the most popular series, but it is there just in case need be. And also it's there just because I like it. And in a way it is sort of an excuse for a video. But anyway, this is just going to be math videos pretty much. What I have is I have a, well, I call it an art pad. Basically it's a black pad with a pen, so I can write whatever I want. Yeah, that is my actual handwriting. It is atrocious. And I made my way through all my GCSEs with this. I also had to help a bunch of friends using the tools provided on Paint and also this art pad. So what I'm going to do is I'm going to teach the basic level of algebra. I'm going to go through all kinds of graphs, such as linear, quadratics, cubics, quartics, even quintics as well. Maybe 6th degree. I don't really know. From there, I teach like principles of graphs, how to solve graphs. Stepping slightly away from, like, I say slightly away from graphs, I'll head into calculus, which is pretty much graphs at the same time as well, among a bunch of other things. I'll also do some A-level further maths principles, and also some GCSE further maths principles, i.e. Imaginary numbers. There's also like Argand diagrams, pretty much just an ordinary diagram, but it has some other meanings to it. Argand diagrams, series, and also matrices as well. 1, 0, 0, 1. Yeah, because some of this stuff is, in my opinion, quite difficult. But we're not going to start there. Now we're going to start at the very basic. So, like pretty much where algebra would be used in like day to day. So, like, say for example, you had 7 objects, and a friend of you gave you an unknown amount, which we always label as x. Okay, whenever we're doing basic algebra involving real numbers denoted as that, which we will come on to much later, we always use x. Okay, give you 7. You have 7 objects initially. Someone gave you an unknown amount, known as x, or x amount, and you are left with 10. Now, obviously, the answer seems obvious. X is 3. I mean, I'm sure you went through this, like, in primary school easily, that 0, 1, 2, 3, 4, so on and so forth, matches up with 10, 9, 8, 7, 6, and there's also 5 and 5 as well. So, like, clearly that is one of the ones that's going to match here. But, given the circumstances, I'm going to teach it slightly differently. And the way I teach it is, like, definitely important. So, what we want to do is we want to get x on its own. Now, what I'm going to do is I'm going to, like, this is, at the end of it, an equation, alright? There's 3 things in maths. There's an equation, there is an expression, and there's a formula. So, a formula would be something like PV equals nRT, okay, where P equals pressure, and you have to plug in a value for P, etc., etc. An expression will be something like A squared plus R, right? There is no equals sign, okay? And then an equation is obviously something like this, right? It has an equals sign, but it also has some unknowns within it, but also it can also have no unknowns. 1 plus 2 equals 3. That is, in a way, technically an equation. Oh my goodness. Right, there is chaos going on. I might need to mute that because that might have copyright on it. It is technically the morning, and I need to get to school at some point in time. But however, I've timed everything nicely. So, well, what do we know about this equation? Well, 7 here does not have a negative sign in front of it, which means that technically 7 is positive. So if we were to minus a 7 from both sides, whoops, okay, these 7's here would cancel out, leaving just x on this side of the equation. 10 minus 7 is 3, which is the answer, and I always like to put a box around it. Right, and that's pretty much what we knew at the beginning. 7 plus 3 is 10, or 7 plus the unknown is 10. And we figured out the unknown to be 3. This is just the basic principle of working around with these types of equations, and you almost definitely need to get used to it. So if you have an unknown amount to begin with, and by the way, write x's like this, write them curved. You can also join them up a little bit. It's a little bit icky. The reason why is because if you write x's like that, you have the time symbol. I mean, they're the exact same, right? It's pretty much like when you're writing, there was another one. But anyway, like 2's, z's always have to have a line through them. 7's, they can have a line through them. I just don't normally draw 7's with a line through them. Anyway, and I did mention z. We'll come on to that. That sort of relates to that. But anyway, if we have x minus 3 equals 5, right, obviously you can kind of figure out that this is going to be 8, right? But not doing it this way, and we'll come on to why you don't do it this way in a bit, you would do the opposite of what's going to happen here. So you wouldn't minus 3 from both sides. Minusing 3 from both sides would turn this into a 6, which does not help us. So you need to add 3. So these two will cancel out, and if you add 3 to this side, you are left with x equals 8, which is what we knew in the start, right? Now, this all seems completely pointless and doesn't entirely make sense. Why are we doing something like this? Why are we adding in extra steps to get towards an answer that we already know? Well, if we were to do, I don't have a random number gen. I have dice. Why can't I just use them? If we were to do something like 6 subtract x. No, I'm going to do plus there. 6 subtract x is 9. Obviously, that is 3. Yeah. But just to add in like the added confusion, what if there was a 2 in front of the x? What if there was a plus x over here? What if they were divided by something? Right? Well, obviously in this case you're just I don't even think you can cancel out the x's. No, you'll be left with 9 over x plus 1. But like this is the point. Okay, and also when we get onto some quadratic stuff, you have to sort of get used to doing it like this and not just assuming that 1 is 1. I mean, x is what it looks like it is, because sometimes it won't be. So instead of writing something like minus 6 on both sides, I normally write it in the middle. Minus 6. So like it is implied that it goes to all sides. So these two cancel out, so you're left with x equals 3, obviously. Now, there is a fine line between what you can and can't do in an equation, like minusing 6. It's a little bit difficult to explain, but it's pretty obvious what you can and can't do. But like that's coming from someone who almost speaks mathematical language. Now, let's actually head on to a different example that I almost showcased there. 2 plus 3x equals 8. Now, there is a number in front of x, meaning that when we do the old faithful minus 2 from both sides, we get 3x equals 6. Now, this seems obvious, but for those of you who do not understand the basic principle that whenever there is a number in front of an unknown, that's basically like having a number in front of another number in brackets, okay? But we don't put the x in brackets because, well, I mean, it's a letter. This just means multiplied. So 3 times 6 is 18. So, but because there is a 3 in front of the x, and this means they're multiplied, if we divide by 3, 3 times, hang on, if we do 3 times 6 all over 3, right? This is pretty much 3 times x divide 3. This is the same as 18 over 3, which just equals 6, right? And what we can do is we can also just cancel them two out, getting 6 on its own. So we're left with x equals 6. Idiot. No. Here we're left with x equals 2. Now, obviously I've shown all of them, and I did sort of show what you do to multiply, you divide, at the wrong time, I guess. So if we were to do something like 11 plus x over 9 equals 3, I really hope that these don't turn into some horrible numbers. Because we're dividing by 9, what you multiply by 9, right? Because then these two cancel out, you're left with 11 plus x equals 3 multiplied by 9, which is 27. Alright, subtract 11, x equals nope, 16. Yeah, that is right. I don't know why I fumbled on that. My mental maths is not the best, but I mean, in terms of like complex maths, it's sufficient. Yeah, that's all well and good. Now, what if we head into negative numbers? So 1 minus x equals 3. Now, 1 is obviously positive, so if you minus 1, we are left with minus x equals 2. Now, the reason why this didn't apply earlier is because when x is positive and there is a number in front of it, as soon as you remove the number, right, it's just the same as positive x, which is literally just the same as x, right? Negative x cannot be, right, is not equal to the same as x, right? So there is a difference there, pretty much. So what you do is you invert the signs. The way I like to show that I'm inverting the signs is I draw plus, minus, and then stupid pen. Plus, minus, and then I draw arrows towards them. So basically, you turn positives into negatives and negatives into positives. So this becomes x is minus 2. Right? Because there is a plus sign here, we just don't draw it. I mean, it would be a waste of time. But then again, up here, this does make sense. 1 minus minus 2. Right, this doesn't mean multiply because there's a sign in front of it. 1 minus minus 2. Minus and a minus become a positive. So 1 plus 2 is obviously 3. Right? Simple enough. Now, there is one thing I did show earlier as well, which is when you have an unknown on both sides. So 2 plus 2x equals 16 minus 3x. Ugh, I don't know. So there's really two ways to go about this. I was always taught what you need to do is you get rid of the smallest unknown. Now, the smallest unknown is negative 3x. So what you do is you plus 3x to do the opposite. So that cancels out. You're left with 2 plus 5x equals 16. Subtract 2. Oh god, 5x equals 14. I'm actually just going to change this real quick. I'm going to change this into 17. So then we're left with 15. Just to make the numbers nicer. So then you divide by 5. X equals 3. Okay? And then does this make sense, right? 2 plus 2 bracket 3 equals 17 minus 3 bracket 3. So what this is it is 2 plus 6, which is 8, is equal to 17 minus 9, which is also 8. Yeah, so that does work out. But what you can do is you don't actually have to minus the, or like get rid of the smallest x. You can do this the other way around. It would make numbers a little bit more challenging, but you know, if you like a challenge, then feel free. And that's sort of why I do like all the complex maths, because I like the challenge. Could you muck about with the numbers? I haven't done it before when you muck about with the numbers. I'll give that a try. Minus 2x. We were always taught to like muck about with the x's first. Equals 2 minus 7. 2 equals 17 minus 5. Now I can see where this is going. Minus 17 is minus 15. Oh, whoops. Equals minus 5x. Now what you can do here is just divide by minus 5, because you're dividing by a minus, and that just becomes a positive, so you get positive 3x. Now, I will try to find an example where this doesn't work, but if you were to just immediately minus 2 from the whole, this is still an equation, you're left with 2x equals 15 minus 3x, and then obviously you add 3x and then divide by 5. What I'm doing is I'm doing more steps at once, so then that becomes over there, divide by 5, x is 3. Now I'm only doing multiple steps at once, because this is very easy compared to some of the other things. And obviously, because I don't want to become a proper maths teacher, no homework, obviously. But if you are interested in it, I mean, there are some fairly obvious obvious? There are an awful lot of websites out there that can easily just supply questions like this. Is that it? I think that's pretty much it for regular. Well, actually, no, there's a couple other things. We'll do basic expansion. So, 2 brackets x plus 3. Now, what happens here is the number inside the bracket is a value. We don't know what value it is because of the x. So this is just basically, that means equivalent to. Does it mean equivalent to? No, that means identical to. Right, okay, whoops. Equivalent to is that symbol. So this is equivalent to 2 lots of y. Now, we don't know what y is, and obviously, to not overcomplicate things, we will not be using y. Now, what you're meant to do here is you're just literally meant to multiply 2 by everything inside the bracket separately. So, 2x plus 3. But obviously we haven't set this equal to anything yet, so we'll call this x. So this is equal to x minus 3 minus x. You're left with x, or 1x equals minus 3. Fair enough. So plugging this into the equation, right? What? Minus 3 plus 3 is 0. Multiplied by 2 would also be 0. And that's not equal to minus 3. What the hell? Oh my god! Right, that should be a 6. Right, minus 6, x is minus 6. Aye, aye, aye. Alright, so minus 6 plus 3 is just minus 3, times 2 is minus 6, which is obviously equal to the minus 6x there. I don't know why I didn't see that, and my phone is ringing, and it stops. Alright. Yeah, so this is expanding, pretty much. There is expanding and simplifying, which we will come on to in a bit. You know, we could do an expansion, like a double bracket expansion right now. So x plus 2, x minus 2. No, actually, no, that's a conjugate pair. We're not going to do that. Right, so this is a double bracket expansion. Pretty much what's happening here is these two are timesing together. However, we don't write the time sign. We just normally write the brackets very close to each other. Where's the... Alright, that's handy. Fair enough. Oh, Jesus. Now, what happens here, and this is where it gets a little bit more complicated and we get into graph territory. This quantity is being multiplied by that, this quantity is being multiplied by that. This quantity is being multiplied by that, this quantity is being multiplied by that. Okay? Seems complicated at first, and to be honest, the first set of working you do on this will get complicating. Will be very complicated. I'm going to make that plus, just for what's about to happen. Okay, but there is a very easy method to get around expanding these things. So the reason why it says expand and simplify is because x times x is x squared. That's a little bit like 5 times 5 is 25, and 5 squared is also 25. Alright? But we just have unknowns. So x squared, alright? X times 1 is, well, 1x, or x. 2 times x is 2x, and then 2 times 1 is just 2. So if we simplify this, we're left with x squared plus 3x plus 2. Okay? Now, the pattern is that, like, look at the numbers here. Okay, 1 and 2, and then there's a 3 here, and there's a 2 here. I'm going to do another example, and I'll leave that one up on the screen just to try and figure out what the pattern is. Okay, and I want to see if I can do it algebraically, because I will be doing an awful lot of algebraic explanations. X plus 6, x plus 4. Why not? It should be fairly obvious. So x squared, right, plus 4x plus 6x plus 24. Right, now what happens is pretty much these two are the only thing you have to muck about with. X squared plus 10x plus 24. You see the pattern already? You add the two numbers to get the number in front of x, and then you multiply them together to get the last number. So what this pretty much means, and I will explain what I just said, x plus 3, x plus 4, you can literally just do this by looking at it, right? X squared plus 7x plus 12, right? You add the two numbers together to make the number in front of x, multiply the two numbers to get the constant at the end, right? Ooh, but what if that was negative? Same principle. Right, x minus 2 this time. Right, x squared plus x minus 6, right? 3 plus minus 2 is 1. 3 times minus 2 is 6, okay? And I will use some algebra here, right? If a times b equals c, right? A times minus b equals minus c, right? Minus a times minus times b equals minus c, minus a times minus b equals c. Now, this does seem like a lot, obviously, and I do have an awful lot of people complaining to me about the number of letters, or like the quantity of letters that I use in formulae. This is nothing compared to other things for a start. Now, also, this shouldn't seem that confusing, right? Although it is letters in a topic specifically devoted to numbers, right? What these are formulae, all right? If you have a number, like for example 3, we'll substitute 3 for A and 2 for B. Because 2 is negative, the result, which is C, is negative, all right? Multiplying A and B together will always get you C, but depending on where the negative sign is, it'll be negative C sometimes. If the negative sign occupies one, at least one of the variables, then it is negative. If it occupies 2, then it is positive. If it occupies 3, well, actually, if it occupies more than that, it starts to get a little bit more complicated, which we could do at another time, I guess. Now, actually, what I just showed you was a quadratic. And I'm going to head on to something quite interesting now. So, x plus 1 squared. What is this? Now, I believe I am guilty of doing this in the past. Multiple other people are guilty of doing this as well. This is not, right, it's not the same as this, where you multiply that and you multiply that. No, it's not the same as that, okay? It's not the same principle where you go x squared plus 1 squared, okay, which is literally just x squared plus 1. No, it is not that, okay? And I've seen this an awful lot, alright? I do not know how to pay tax after school. I do not know how to get a job. All I know is that a plus b in brackets squared equals a squared plus b squared. No, it does not, right? What this is identical to, and this is where I actually need to use this sign, x plus 1, right? Because think about this. This is the same. If this was y, this would be the same as y squared, which is identical to y times y, which is pretty much this principle. Now, there are several patterns that you can copy here. Obviously, the answer will be x squared plus 2x plus 1, alright? Meaning that the answer up here should be a squared plus 2ab plus b squared, okay? And there is a reason as to why this works as well, called the binomial expansion. I'll go over this version as well. I'll go over this as well, just to make it clearer and just to make multiplying brackets with a power a little bit more easier, okay? So the binomial expansion links onto the not Sierpinski triangle. It links onto Pascal's triangle, which is 1, 1, 1.
2,000 years later.
Right, my mum just left a dog in the room. Alright, yeah, so 1, 1, 2, 1. Okay, it does go on a little bit further, but we'll ignore this for now because this involves cubics. Now, the way this works is like 1 plus 1 is 2, 1 plus nothing is 1, alright? That's sort of how this works. Now, whenever you have something like a plus b, and again, this is technically a formula, or like an expressive formula, because it doesn't equal anything. Whenever you have a plus b to the power of 2, what you do, right, is you do 1 multiplied by a to the power of 2, b to the power of 0, plus 2, a to the power of 1, b to the power of 1, plus 1, a to the power of 0, b to the power of 2. Now these are all multiplied, right, in between all the pluses, okay? So what's happening here is the a gets the starting power and then goes down every single term until it hits 0. B gets 0 power and then increases until it reaches this power. Right? The number multiplied in front is literally just the number here. I mean, I know it's quite mundane given that you have 1, 1, 1 and 1, 2, 1. But I mean, when you get further on, where you get like 1, 3, 3, 1, or 1, 4, 6, 4, 1, that's where it starts to get a little bit more interesting. Now, I'm going to rub all of this off, and I kind of have to go now, so I'll wrap this up. Right, 1, you don't normally write 1s in front of things. Anything to the power of 0 literally equals 1. So you're multiplying this by 1, so you're just left with a squared. Okay. 2, a to the power of 1 is just a, so there's no point rewriting anything important there. Plus, that's going to be 1, so you're left with b squared. This is obviously what I got earlier. Now if we were to do the a plus b, hang on, when do I leave? Leave at 40 part. I got time, Jesus. But I'll probably end it here anyway. A times a is a squared. A times b is a b. B times a is technically ba, but we normally write it as a b in alphabetical order. Oi, shush, I'll let you out in a bit. Plus b squared. This is obviously equivalent to a squared plus 2ab, as these are like terms, plus b squared, which is literally what I got just here. Okay, now these are, in a sense, quadratics, because more or less because they include the x squared term. X plus 1 equals y, x squared plus x plus 1 equals y. So this is what's called a linear, okay? And we were looking at these earlier, right? X plus 1, and it looks a little bit like x plus 1 squared. And we'll come on to this in a minute. Well, I mean, not in a minute, some other time. Alright, this is a quadratic because of the squared sign. And we'll show what signs these make in graphs, okay? Because when it gets into graphs, this is where it gets more complicated. What we want to know in graphs is pretty much just the turning point, which is there. We also know what the points when it crosses the x-axis. We also kind of want to know the points in which where it crosses the y-axis, depending on things. You know, and also at some points in time, you might even ask for a gradient or a normal, depending on what the question is. So this is the start to algebra. I haven't gone on to absolutely every single topic because most of it is quite mundane and self-explanatory. Alright, whatever you do to get an object onto the other side, you have to do the opposite of it, pretty much. I haven't done anything with powers yet because, I mean, in my opinion, too many powers and too many letters seems quite complicated for people. Right, and I should know because I really annoyed some people back in the day when I was just too good at this sort of thing. And I kid you not, I wrote almost half a page of formulae that was just letters. But obviously none of that stuff should happen now, at least. So thank you so much for watching. Hey, can I do this? I spelled that wrong. Whoops. Whoops. Leave a like, comment and subscribe. Thank you so much for watching.